Okay, just some examples of Archimedes and upthrust. There is a video on Moodle which should be with you somewhere on this stuff. Archimedes and upthrust. So there's a couple of examples on that one. So here's some extra ones that I'll work through with you. Based on the same stuff really, where you've got something floating in water like this, or oil or whatever it is. You've got an upthrust force coming that way and a mass coming down that way. So this one is it's a pole, say, with 120 mil diameter. It's in sea water, and the it's submerged with a depth of 6 meters. So this depth here, say, is 6. There's 6. Density of seawater is 1030, so we need to work out what's the upthrust here. Look, what's the upthrust on this pole, keeping this thing floating, really. So we know from previous life that the upthrust on this is going to be density, gravity, height, and area. We know the density, it's 1030. We know gravity is 9.81. We know the height, it's 6. We can work out the area, so it's a cylindrical pole, so it looks like that, circle obviously, and it's 120 diameter, millimeters. So the cross-sectional area, the area of all of this, because the more area you've got, the more pressure, the more force. So area of a circle, pi d squared over 4, or you could use pi r squared, it's up to you. Pi r squared. So area is pi d squared over 4. Obviously diameter's got to be in meters, that's why I've done to the -3. So we can do 120, divide that by 1000. We'll square that, times it by shift pi equals that, and divide that by 4. One way of doing it. 0.01. I've made that a 4. Well, hang on. Yeah, I've gone up a bit now. It's 113 really, isn't it? So 0.0113. Yes, it shouldn't really be a 4 there, but so that's the area. So now I know density, gravity, height, and the area. So I'll use this as the area. So there's the area times by 6 times by 9.81 times by the density. Gives me 685. So obviously that was using that as the area. Obviously I've rounded up here a bit, right? So I've used that in this calculation. So it shows you how much of a error you can make if you don't use the proper numbers. So using this here, 1030 times by 9.81 times by 6 times by 0.0114, 691. So whatever this thing is floating, the upthrust force is 691. That's how much force is going up. Newtons, obviously. So while we're here, we want to try and work out the mass of the pole, perhaps, because we know that there's a weight coming down due to this pole, m times g, the mass of the pole and gravity. So whatever's coming, so that force is coming down, that's going to be balanced out by this force coming up. So we know from that video that mg equals density, gravity, height, and area. So mg is coming down, m being the mass, g being gravity, and all of this we know is 691. I'll stick with my number there, 691. So we know that mg is all of that, and we know that all of this equals 691. So I'm going to bring this gravity down here now. So there was the mg, there was the gravity, I brought it down. Okay, So there's two ways you can do this. This is one way. We know that all of this, that upthrust force is 691 and gravity is 9.81. So 691 divided by 9.81. 691 divided by 9.81 gives me 70.4 and a bit. That's the mass, kilograms. Or you could go this way. So we know this formula. We know this formula here. And this way I've cancelled out the gravities because G over G, so you cancel them out. So you end up with just density, height and area. So you do it that way, you get the same answer. So this one, density, height and area. So 1030 times by 6 times by 0.0114. So you get the same answer. So either way is right. So the mass of this thing is 70 kilograms. Number 2, a body of square now, cross-sectional area, so it's a square thing. 70 by 70 mil, do it like that, 70 by 70. Mass of 50 kilograms. If it is placed in a liquid of relative density 0.85, this is relative density. Calculate the length that will be submerged. So we know whatever this thing is, it's square, floating in water. The mass of this is 50 kilograms. The density of this is 0.85, relative density to water. We need to find H. So here's the formula. We know M, we know G, we know density, we can work it out. We know gravity, we don't know the H. We know A because we can work it out. So the density we know is 0.85 relative. So to get that into the number we can use, it's relative to water, and water is 1,000. So 1,000 times by that gives you that. You shouldn't really need a calculator to do that, if you don't believe me. So this is the density we're going to use, 850. And the area is, it's 70 by 70 square, so it's just a square. So to find the area, we'll just do that. So we can do 70 by 70, like. Obviously, I'm dividing by 1,000 to get it into meters. That's what this -3 is all about. So 4.9 square meters, -3 on it. That's the area. So what I've done here now is I've rearranged this formula for H. Basically, I brought the density, the gravity, and the area from up here down to there. That's what I've done there. So the gravity comes down, the area comes down, and so does the density. That leaves me with H up here. Like I did before, to make it easy, you can leave it in if you want to, but the gravities cancel out. You can leave them in if you want to, but you'll get the same answer. So that G cancels that G out, so now I've got that formula, no G. So just mass over density over area. There's my mass. There's my mass. There's my density, and there's my area. So we can do, let's do it this way then, 50. I get the brackets correct. Let's do this way, 850, close that bracket, times by 4.9, 4.9, minus 3, close that bracket, close that bracket. This should give us 12. Ta-da! 12 meters. So this height here, it's floating, submerged 12. So we need to work out now what would the upthrust force be. So there's two ways you can do this, because we know that these should be equal. So mg is coming down and this is the force. So that mg has got to equal that upthrust force. So you could do it that way, where m times g is going to give you 490. That's the force coming down. So 50 is the mass, gravity is the gravity. So that gives us 490. That's coming down though, but we need to find the up thrust. So the up thrust is this one, because that's coming up. The same thing really. You get slightly different answers because the height wasn't exactly 12, so that's why we get slightly different. So really this is the up thrust, so just to make sure everything's correct. So density, gravity, height and area. Density, gravity, height, area. So 850 times by 9.81 times by 12 times by all of that, 4.9 gives me 490. So there we are. So the up thrust is about 490. Obviously the slightly out, because if you remember this 12 wasn't exactly 12. So that's the up thrust force on that thing. Question 3, last one I think. Yeah. Is the last one? Yeah. So this one, same thing really. You've been asked to calculate the density of an unknown liquid using Archimedes principle. You submerge. So you've got to be liquid. We don't know what the density is, but you've got a pole and you've got something to measure with. We've submerged this circular object of diameter 230 into a container holding the liquid. We know the mass, so that's the diameter. We've measured the mass, say it's 6 kilograms, and we measured, so it sinks in, it submerges to a depth of 0.16, so about 160 mil. It's floating. Calculate the density of the liquid. So we know diameter, which means we can do area, so pi d squared over 4. So there's my area. We'll do 230 minus 3. We'll square that, times it by shift pi, and divide that by 4. 0.042, look, I've gone up. That's the area. We know the mass and we know the height. Here's the formula. mg, density, gravity, height, and area. We don't know the density, but I'm going to rearrange this formula for that. So I'm going to bring the g down, bring the h down, and bring the a down, and leave the density there. So the gravity comes down, the height comes down, and the area comes down. Both that gravity and that gravity cancel out, leaving me with density is mass, height, area. That's my mass, that's my height, and that's the area. So 6 divided by, let's put it in a bracket for laugh, 0.042, close that, come out, equals 892. Density of whatever that is 892. And just to check, I always go to check, I can't spell check, look. mg is rho g h a, so this side has got to equal this side, so there's the mass, there's the gravity, so that times that gives me 58, so 9.81 times by 6, tick, and then this side should equal this side, so density, gravity, height, area, so 892.9 times by 9.81 times by 0.16 times by 0.042 equals, there we are, tick, that equals that. And that's it. So just some questions on Archimedes principle. Watch it along with the video, and I'll put some questions up for you to have a go at. Any problems, let me know. Everyone's a winner.